Hello everyone, my name is Rahul. Today we are going to solve this question, lucky numbers. Okay, let's see what the question is. Lucky numbers are subset of integers which are left after performing some operations on the set of integers from 1 to n. Okay, what does that mean? We will be given with one integer, let's say n equal to 19, and we have to find that if this number is lucky or not. And what the lucky numbers mean is we have to perform some operations from 1 to 19 and see that if 19 is not deleted after performing some operations or not. If it doesn't get deleted, that means it is a lucky number, otherwise it is not. Let's understand it clearly. We have taken a set of integers. That means the integers can be till anywhere. That means it can be till 1000, 2000, 3000, but we are taking an example of n equal to 19. That means we have to find if 19 is lucky number or not. First, let's see what are lucky numbers. Okay. So if we are taking this example, what we have to do is, first thing is we have to delete every second number. That means 2, 4, 6, 8, 10, 12, 14, 16 and 18. That means every second number in this set has to be deleted as the first operation. Okay. Now, what we will do is, we will delete every third number from the set that is left after deleting every second number. Okay. After deleting second number, this is the set that we are getting. Okay. Now, we have to delete every third number. That means 1, 2, 3, 5 is deleted, 1, 2, 3, 11 is deleted, 1, 2, 3, 17 is deleted. Okay. Now, we have to continue this process indefinitely. That means now what we have to do is we have to delete every fourth number. Then we will delete every fifth number. Then we will delete every sixth number and so on. And after these operations, the numbers that are left at the end, which are never deleted and which will never get deleted in this process, are called lucky numbers. And we will be given with some number, let's say n. We have to tell them that if this number is lucky or not. That means if it is left in this set after performing these operations or not. Okay. Now let's take one example and understand it better. Let's see for n equal to 15. That means we have to tell if 15 is lucky number or not. Now what we will do for this is we are taking an array of 15 numbers. Okay. I have written the indexes as well, as they will be performing an important role in this question. Now, what was the first operation? We have to delete every second number from this array. So for that, we will take a variable counter. Let's take its value as 2. Okay. It will represent that in every iteration, which numbers has to be deleted. That means the numbers which are divisible by this counter value has to be deleted. Not the numbers, the indexes of the numbers which are divisible by this counter value has to be deleted. Let's see how. At first, we have to delete every second number. Okay, so 2 will be deleted, 4 will be deleted, 6 will be deleted, 8, 10, 12, 14. These numbers will get deleted. That means all the numbers whose indexes value is divisible by this counter value has to be deleted. Okay, 2 is divisible by 2, so it will get deleted. 4 is divisible by 2, so it will get deleted, and so on. Okay, now the array which is left after deleting every second element is this: 1, 3, 5, 7, 9, 11, 13 and 15. Okay. Now the indexes of these numbers will get changed because the array only consists of 8 numbers now. So we will have 1, 2, 3, 4, 5, 6, 7, 8 numbers. In this array, we have to delete every third number now. So we will increase the counter value. It will become 3. That means the index which are divisible by 3 will get deleted. Okay, that means 1, 2, 3, 5 will get deleted. 1, 2, 3, 11 will get deleted. Okay, now the array which is left after deleting every third element is this. That means 5 and 11 got deleted and we are left with 1, 3, 7, 9, 13 and 15. Now the indexes are changed 1, 2, 3, 4, 5, 6 because only 6 elements are left. We will increase the counter value to 4. That means we have to delete every fourth number now. So the index which is divisible by 4 has to be deleted. So 9 will get deleted. Then the array left after deleting 9 is this 1, 3, 7, 13 and 15. Now we have to increase the counter value. Now it will be 5 and the indexes which are divisible by 5 will get deleted. Okay, so 15 will get deleted. That means the thing we were finding in the starting, that is that 15 is lucky number or not, we have reached our conclusion in the process that 15 got deleted here and it is not a lucky number. Okay, because lucky numbers are those which are left at the end without getting deleted when we keep repeating this process again and again. Okay, so here 15 got deleted, so we can say that 15 is not a lucky number. Okay, but we have to see for the process where it got deleted. So if we find that the number we need to find is lucky or not, if its index is divisible by the counter value at that point, it means at that iteration, if the counter value is divisible by the index at which the lucky number we need to find is there, that means it will get deleted and it is not a lucky number. So let me write it here. If lucky number index is divisible by counter value at that iteration, that means we have to return false, which means it is not a lucky number. But let's continue this process and we will see when we have to stop. That means as it got deleted here, we will stop at this point only in this question. But if there is some other example and that number is not getting deleted in the process, then when we have to stop and return true, that if it is lucky or not. Let's see that. Okay. So after this, we will get this array and our counter value will be increased to 6. Okay. That means every 6 number has to be deleted now. But there are only 4 numbers left in this array. So 6 number cannot be deleted. So we have to stop here. That means if we keep on increasing this counter value, that will not affect this remaining array. These values will never get deleted now. And these all are lucky numbers. So we got one more condition when we have to stop deleting the elements. This condition is if the number of elements in the array which are left are less than the counter value, then we have to return true. That means the number that we are trying to find out that if it is lucky or not will never get deleted if we reach this condition. Okay. So let's see these conditions and write them on the next page. So these were the two conditions that I wrote in the previous slide, that if the index of number is divisible by the counter value, then we have to return false. Otherwise, if number of elements in the array left are less than the counter value, then we will return true. Okay. So let's take one more example, which is n equal to 7, a smaller example. So in this example, what we are doing is we are taking 3, 4, 5, 6, 7. These are the indexes and these are the numbers of the array. Okay. So first we have to delete every second element. That means we have to delete 2, 4 and 6. So first of all, what we are doing is we are taking the array till the number we have to find if it is lucky or not, right? If n is 7, then we are taking the size of array as 7. If it will be 100, we have to take the size of array as 100, right? So if we do not want to use the array, how we can do this question, right? We have to see that. So at this point, we will see that thing. So first we will delete every second element, then 1, 3, 5 and 7 will be left, and the indexes will get changed as well. Okay. Now we have to delete every third element. That means 5 will get deleted as its index is divisible by 3. Now we are left with 1, 3 and 7. Now indexes of these will be 1, 2, 3. But now we have to delete every fourth element, right? But there is no fourth element, and we have reached this condition that if counter value is greater than the number of elements in the array. So we have to return true. That means 7 is lucky number, right? So one more thing is we can see that we are taking only array till the number we have to find if it is lucky or not. Okay, that means the number will always be at the last index of the array. So this way we can find that the number of elements in the array will be equal to the index of 7. That means the number we need to find if it is lucky or not, its index will be same as the number of elements in the array, right? So we need not worry about the size of the array. We have removed one of the conditions of using array at this point. Now we need to find the index of number every time we are deleting some elements from the array, right? But see here, we have to find if 7 is lucky or not, right? So we just need the index of 7. Every time when we are calling the function again, we will just send the index of 7, right? As it is changing at every iteration. First it was 7, then it became 4, then it became 3. So as it is changing, we have to see just that how it is changing. There is a pattern and we will find out that. So let's see what that pattern is. First it was 7, then 3 numbers got deleted. So it became 7 minus 3, which is 4. As it is the last element of the array, then the numbers will only get deleted before this number only, right? So, or either it will get deleted or the numbers before this will get deleted. For the condition that if it is get deleted, then the question is over, then we can say that it is not a lucky number. We have found that from this condition and we have seen it in the previous slide as well, right? Now let's see how we can find the index of 7 every time. First it was 7, we deleted 3 numbers, it became 4. Now we deleted one number and it will become 4 minus 1 is equal to 3. Now in next iteration it will be 3. So just we have to do is we have to find how many numbers will get deleted before 7. How we can do that? It's very simple. So there are 7 numbers in the array in the starting and 3 numbers are getting deleted. That means 7 by 2 numbers are getting deleted. It will become 7 minus 3, which is equal to 4. Next, we have 4, right? Now, every third number has to be deleted. That means counter value at this point will be 3. So, we have to do is 4 minus 4 by 3. It is 4 minus 1, which is equal to 3, right? So, next time it will be indexed as 3. Now, every fourth number has to be deleted. That means the counter value will be 4, but we will reach this condition that the counter value became greater than the index of 7, which we have already found, which is 3. So as 4 is greater than 3, it will return true from this condition. So what we have found out is we just need the index of that number, which we need to find if it is lucky or not every time. And what we will do is we will define a function here and keep passing the value of index there only and keep calling the recursive function, right? So let's see after this how this code will look like. Now let's understand the code for the question we have discussed before, that is lucky number. Okay, so as you can see, first we initialized our counter value, right? This counter value represents every time which numbers has to be deleted. That means in the starting, that means the first iteration, we have to delete every second number. So the value of counter is 2. Next time it will be increased to 3. That means every third number will be deleted and so on. Now let's move forward. We have defined a function is lucky and we have given an integer n to it. N is what we have discussed before, the number that we need to find if it is lucky or not. So these two are the conditions that we have discussed before as well. That means if counter is greater than n, then we have to return true. Otherwise, if counter value gets divisible by n, then we have to return false. And this is the condition that we have to change the n every time before sending it again to the same function. This is representing the index that we considered before as well. Counter value gets increased every time before the function is called again, because every time it will get increased and the same number will be get deleted. And then we have to return the function. Let's take an example and understand this code clearly. Let's take the same example of n equal to 7. First, we will see if counter is greater than n. That means 2 is greater than 7. But it is not. Then we will move forward. If n is divisible by counter, that means if 7 is divisible by 2, that is also not true, then we will move forward. But let's see what are these conditions by using the array 2, 3, 4, 5, 6 and 7, and their indexes 1, 2, 3, 4, 5, 6 and 7. What these two conditions represent is, first condition is telling that if the value that has to be deleted from this array is there or not. That means if the size of the array is less than the counter value, that means there is no number that we can delete. So that is what we are checking here. Then we can return true. That means we have reached the condition where no number will get further deleted and we have to return true there. The next condition is representing that if the number that we need to find is lucky or not, that is 7, if its index is divisible by the counter value. That means at that time, what that number is deleted or not. That means in the starting, 2, 4, 6 will get deleted, right? And 7 will not get deleted, which is because the index of 7 is not divisible by counter value. All the other values whose indexes are divisible by the counter value gets deleted. That means 2, 4, 6 will get deleted as they are multiple of 2. Then next time, how many numbers are left and what is the index of 7? Numbers left are 1, 3, 5 and 7 and indexes will be 1, 2, 3 and 4. Let's see if the index of 7 is 4 using this formula. Let's see. We have n equal to 7 in the starting. What we have to do is we have to subtract 7 minus n is 7 by counter is 2. So what we are getting is 7 minus 3, which is equal to 4. Okay. So this is same. That means the index of 7 in the array that we were taking before and the value of 7. That means the index of 7 that we are finding with this formula is coming out to be same. Then we increase our counter value. That means in the next iteration, we have to delete every third element. Okay. Then we call the function again. That means right now n is equal to 4 and we are calling the function is lucky with value 4. Okay. Now we will see if we have reached the condition, the first condition, which is counter is greater than n, but it is not, as counter is 3 and third index is present. At least one of the index which is divisible by 3 is present in the array. So it will not be satisfied. Then we'll come to next. That means if the index of 7 is divisible by the counter value. That means if it is getting deleted in this iteration or not. But it is not divisible, so we will move forward. And as we have discussed, 5 will get deleted and we will get 1, 3 and 7 only. And their indexes will be 1, 2 and 3. Let's write it here. Okay. First let's delete this from here. and we will write it here. We will get 1, 3 and 7, and their indexes will be 1, 2 and 3. And from this formula, 4 minus 4 by 3, which is 4 minus 4 by counter, which is 3 at this time, will be 4 minus 1, which is equal to 3, and which is same as the index of 7 that we were considering as the array. Okay. Now counter will get increased. It will become 4, and we will call is lucky with the value 3 only, because it has become 3. So it will be 3. Now is lucky is called for value 3. Now the counter value is 4, and we have only 3 elements of the array, or we can say the index of 7 is 3, or we can say our n value, which we are changing every time, is less than the counter value. That means there is nothing left in the array which we can delete. Even we cannot delete one element from the array. So we have reached this condition that if counter is greater than n, return true. That means if 4 is greater than 3, at this point counter is 4 and n is 3 that we have passed, so it will return true. And now as we can see, the value of counter is greater than n, which is 4 is greater than 3, then we will return true. Okay, and we can say that it is a lucky number. That means 7 is a lucky number. Now let's see the C++ implementation of this question as well. Okay, so the concept is exactly same. What we have to do here is we have to use some hash includes. Here we have to define bool int. We have to use namespace std. We need not to create the class. We will just make a function bool is lucky int n, and everything else as we have seen above as well, it is same. If counter is greater than n, we will return 1. Otherwise, if n is divisible by counter, then we will return 0. Instead of 1 and 0 in the Java code, there was true and false. Okay. Now, and we have to do the same thing here as well, same as the Java code. The logic is same, only some syntax is different. Okay. Now, if we want to call from C++ code, what we have to do is we will say if is lucky x, that means if that function is returning 1, then we will print 5 is a lucky number. Cout x is a lucky number. Else what we will do is we will say x is not a lucky number. That means 5 is not a lucky number. Okay. Now let's see the time complexity of this function. Let's see the time complexity of this function. So every time when it is calling, the n value is decreasing. That means if we take the example of 15, first it was 15, then it became 15 minus 15 by 2, which is equal to 15 minus 7, which was 8. Then 8 minus 8 by 3, it became 8 minus 2, which is equal to 6. Then 6 minus 6 by 4, which is equal to 6 minus 1, which is equal to 5. And then 5 minus 5, which is equal to 0. 5 minus, sorry, this condition will not apply as this condition will hold true. So there were only 3 steps here. If we found if it is false or not. Okay, here it will be false. So there were only 3 steps, right? That means almost it is equal to root of n, which is root of 15, which is almost equal to 4. Okay, in the 4th step, we found that it is not equal to lucky number. That 15 is not a lucky number. Okay, so what we are doing every time is first time value was n, we did n by 2. Then next time what we did was the same value n by 2. We will be deleting from this by 3. Then next time what we will do is we will delete this value by 4, and this way we will continue, right? Every time n is decreasing, so this value when we calculate, it is equal to root of n, and we can apply on any example this for, let's take 7. For 7, first it was 7 minus 7 by 2, which is equal to 7 by 3, which is equal to 4. Then 4 minus 4 by 3, which is equal to 4 minus 1, which is equal to 3. Then we found this condition. So only 2 times value the function will be called actually 3 times, because it will keep on doing it. Because at the third time we found that if it is true or false, so it is almost equal to root 7, C value of root 7, which is equal to 3. Maximum of 3 operations will be there. So the complexity of this operation is big of root n, time complexity. And space complexity, as you can see, every time the stack will be filled, first it will be lucky of 7, lucky 7. This is the function name, is lucky 7, then is lucky 3, 3, then is lucky, is lucky 4, then is lucky 3. And then we will return from here, then we will return from here. So it is also equal to big of root n. That means the maximum space it can take in a stack is equal to big of root n. Okay, I think you got this question. Thank you.